Saturn's rings, luminous, fragile, and seemingly eternal, are vanishing before our eyes. In the scale of cosmic time, they are already slipping away, and what human beings admire through telescopes today may not survive long enough for future civilizations to witness. Astronomers, once certain that these structures represented permanence, now acknowledge they are only temporary, a delicate ornament destined to dissolve into the very planet it encircles. This impermanence forces us to confront not only the transience of the solar system, but also the illusions of stability we carry into our own lives. The rings stretch wider than the distance from Earth to the Moon, yet are thinner than the width of a single city. To the human eye, they appear unchanging, a symbol of cosmic order, but instruments reveal a relentless process of decay. Material is falling away every second, raining down onto Saturn in an invisible storm. What appears whole and solid is, in reality, a system of fragments in perpetual collision, an immense halo that survives only through constant destruction and renewal. The very sight that has enchanted observers for centuries is, in measurable terms, vanishing. The paradox of Saturn's rings is not just astronomical. It reflects the mind's own susceptibility to illusions of permanence. Psychological research shows that humans are biased toward seeing stability, even when systems are fragile. Neuroscientist Bruce Hood describes this as the essentialist bias, a tendency to believe in the lasting essence of objects, people, and institutions. Saturn's rings, glowing in the night sky, activate this very bias. We assume they will remain, because they always appear to be there. Yet, much like the illusions created in hypnosis or trance states, the truth lies beneath the surface, where slow erosion rewrites reality unnoticed. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, shattered this illusion. By measuring the rate at which particles drift into Saturn's atmosphere, Cassini revealed that the planet is consuming its own crown. Scientists estimate the system is losing tens of thousands of kilograms of material every minute. To a human mind accustomed to linear time, such a figure may feel distant, almost meaningless. But placed in the broader span of planetary history, it means Saturn's rings are in their final phase, a phenomenon we are witnessing during a narrow window that may never be repeated. This raises an unsettling psychological dimension. What else do we mistake for eternal? Just as cultures once believed monarchies, empires, or even the human soul itself to be unchanging, Saturn's rings remind us that every structure, however immense, is subject to dissolution. The same neural circuits that allow us to experience continuity in memory, stitching fragments of perception into a single narrative, also deceive us into thinking cosmic spectacles remain untouched by time. There is a peculiar irony in the fact that one of the solar system's most spectacular features is not only temporary, but already fading. The Roman philosopher Seneca once wrote that all grandeur carries the seed of its own destruction, a reminder that beauty exists precisely because it is fleeting. Saturn's rings embody that principle on an astronomical scale. Their brilliance is not proof of endurance, but of fragility magnified by distance. And yet, the awareness of their disappearance does not diminish their allure. Instead, it sharpens it. Knowing that what we see through telescopes today may one day be gone, imbues the sight with a kind of urgency. The fragile halo becomes not just an astronomical curiosity, but a mirror to our own impermanence. Just as neuroscientists studying sensory illusions show how fleeting signals can give rise to powerful experiences, Saturn's rings demonstrate that beauty often emerges from structures that cannot last. What we are left with is a tension. Saturn's rings appear eternal, yet they are vanishing. They seem whole, yet they are nothing but fragments. And as we turn to the history of their discovery, it becomes clear that even our understanding of what they are has always been shaped by illusion, error, and gradual revelation that stripped away comforting assumptions without ever resolving the mystery fully. When Galileo Galilei first pointed his crude telescope at Saturn in 1610, he recorded an object unlike any other he had seen in the heavens. The planet appeared to bear strange protrusions, like ears or handles, extending from its sides. Limited by the optical quality of his instrument, Galileo could not resolve their true form. He described them cautiously, as if Saturn were a three-bodied world, a planet with companions fused to its flanks. What he observed was not false but incomplete, a fragment of reality refracted through the lens of both technology and expectation. His confusion illustrates how human perception, even when armed with instruments, is bound by the brain's tendency to fill in gaps with familiar shapes. The cognitive machinery that interprets ambiguous images, what psychologists later called pareidolia, led Galileo to interpret Saturn as strange outlines, as extensions rather than encirclement. It was not until 1655 that Christian Huygens, using a vastly improved telescope of his own design, resolved the puzzle. He described a thin, flat ring surrounding Saturn, detached and without contact with the planet itself. Huygens' announcement carried the weight of revelation. The handles were no longer protrusions, but part of a complete symmetrical system. Yet even this description, though closer to modern accuracy, did not convey the full complexity of what the rings truly were. They were not solid nor smooth, but composed of countless fragments, each following its own orbit, while collectively forming an illusion of uniformity. This very illusion of continuity, where there is only fragmentation, echoes the way the human mind creates the sensation of a stable world from discrete sensory events. Just as the brain stitches together flickering images into the seamless motion of film, so too the fragments of ice and rock generate the false appearance of a solid ring. The rings quickly became more than an astronomical feature. They entered cultural imagination as symbols of harmony, perfection, and cosmic order. In an age when celestial objects were thought to embody divine geometry, Saturn's halo became a metaphor for completeness, an elegant circle unbroken. Renaissance scholars, steeped in Neoplatonic traditions, saw in the rings evidence that the heavens operated on principles hidden from ordinary sight, accessible only through refinement of vision and intellect. Their interpretations aligned with the ancient conviction that reality was layered, the visible world only a surface covering deeper patterns of truth. Saturn, adorned with its ring, became both a scientific object and an emblem of hidden order, a duality that resonates with the mind's own oscillation between perception and projection. By the 19th century, telescopes of increasing precision revealed the rings as systems of divisions and gaps. Giovanni Cassini, after whom NASA's 21st century spacecraft would later be named, identified the broad separation between the outer A ring and the brighter B ring. The Cassini division, as it became known, symbolized both discovery and fragmentation, a visible reminder that what seemed whole was actually segmented, composed of spaces as well as matter. Cognitive scientists studying visual attention often describe how the brain highlights edges, contrasts, and boundaries, carving continuous environments into discrete categories. The Cassini division, discovered through direct observation, functions in a similar way, a boundary imposed by gravitational resonances, shaping material into gaps that echo the brain's tendency to organize perception into structured wholes. What was once a mystery of protrusions had become a revelation of structure, yet always mediated by human expectation. The ring's thinness, measured later at only tens of meters despite their vast lateral span, defied intuition. To comprehend a structure thousands of kilometers wide yet almost paper-thin requires a mental stretching of scale that the brain resists. Psychologists have shown that human intuition about large numbers and proportions is deeply flawed. We default to linear approximations where exponential relationships govern reality. The rings of Saturn embody this dissonance. They look monumental, yet their vertical scale is fragile beyond imagination. It is as if a sheet of gossamer were stretched across planetary distances, surviving not through solidity, but through the balance of orbital mechanics. Every new advance in observational technology transformed not only what astronomers could see, but also how human consciousness interpreted the sight. The shift from Galileo's handles to Huygens' ring to Cassini' divisions demonstrates a gradual peeling away of illusions. Yet each stage left its own imprint, a reminder that knowledge is always shadowed by error, that perception contains as much projection as revelation. Saturn's rings, viewed across centuries, have been less a static object and more a canvas upon which the human mind inscribes its biases, limitations, and aspirations for clarity. And still, beneath the shifting interpretations, the rings themselves maintained their deceptive beauty. When modern spacecraft sent back images of their sprawling arcs, luminous against the blackness of space, humanity was confronted again with the same paradox: how something so delicate could appear so absolute. The rings, like a hypnotic pattern, command attention by their very symmetry. Psychologists studying visual salience describe how repetitive patterns, when extended beyond expected boundaries, induce a trance-like fixation. The rings operate on the same principle, drawing the gaze outward in endless circles, creating a sensation of infinite continuity, when in truth they are confined by gravity's mathematics. In the present age, the wonder evoked by Saturn's rings persists, but it is now shadowed by the recognition of their fragility. Their grandeur conceals constant conflict, collisions, erosions, and subtle losses that unfold at every second. The appearance of eternal stillness masks ceaseless motion, just as neural circuits in the brain mask the flicker of synaptic activity with the experience of continuous thought. This duality, beauty arising from instability, presses forward toward deeper questions about what the rings are made of, and how such fragile fragments could sustain the illusion of permanence for so long while concealing within them the seeds of their eventual disappearance. When instruments sensitive enough to probe the rings at close range were developed, the question of their true composition became unavoidable. For centuries, they were assumed to be solid sheets, luminous disks, or even glass-like bands reflecting sunlight. The refinement of spectroscopy, however, stripped away these illusions. By analyzing the way light scattered through the rings, astronomers identified distinct absorption lines characteristic of water ice. The spectrum revealed not a monolithic structure but particles, fragments composed mostly of frozen water, coated here and there with dust, carbon compounds, and trace minerals. The rings are an ocean of fragments suspended in orbit, each particle obeying Newtonian mechanics as it collides, ricochets and reforms into temporary aggregates. Their scale defies intuitive grasp. Some are as small as grains of sand, others rivaling mountains in dimension. Yet, despite their disparate sizes, they share a choreography defined by Saturn's gravity and the resonances of its many moons. This endless collision system resembles a laboratory of entropy, where order emerges briefly out of chaos before dissolving again. The reflective brilliance of the rings is a consequence of their icy composition. Sunlight scatters across their crystalline surfaces, making them visible even from Earth's distant orbit. But the gleam conceals processes of constant erosion. When particles smash together at orbital velocities, they fracture, splinter, and sometimes fuse. In the violence of these encounters lies the secret of their apparent stillness. What appears serene is built upon perpetual disruption. Neuroscientists studying perception have long noted the brain's ability to transform chaotic signals into stable images, a principle seen in phenomena such as the phi effect, or the perception of continuous tone in fragmented sound. Saturn's rings enact the same paradox on a cosmic scale. Violent disorder resolved into the illusion of an unbroken halo. Among the most intriguing features of the rings are the transient structures that ripple through them. Cassini's instruments detected waves, spirals, and propeller-shaped gaps carved by the gravitational nudges of hidden moonlets. These disturbances echo the way external forces shape neural patterns. A rhythmic input, whether through sound, light, or breath, can synchronize cortical oscillations, inducing trance-like states or altered perception. Just as a repeated rhythm can entrain human brainwaves, the steady pull of Saturn's moons entrains the orbits of countless ring particles, imprinting resonant patterns across a system that should otherwise dissolve into uniform dust. The fragility of these icy fragments becomes evident when considering the forces they endure. Micrometeoroids, traveling at tens of kilometers per second, strike the particles constantly, breaking ice into finer grains and coating it with dark material. Over geological spans, this bombardment should have destroyed the rings entirely. Their continued existence suggests either youth, that they formed relatively recently, or replenishment, perhaps from shattered moons or comets that wandered too close to Saturn's tidal forces. Each hypothesis challenges the assumption of permanence, replacing it with an image of rings as transient phenomena, produced and eroded within the shifting dynamics of the solar system. On Earth, cultural practices often mirrored this same interplay between appearance and dissolution. In Tibetan Buddhism, monks create intricate sand mandalas, painstakingly arranging colored grains into symmetrical patterns, only to sweep them away in ritual destruction. The purpose is to embody impermanence, to show that beauty is inseparable from loss. Saturn's rings are a planetary mandala, composed of ice grains instead of sand, vast beyond human comprehension, yet equally temporary in their design. They endure only through constant rearrangement, only through an endless cycle of creation and disintegration. Modern imaging revealed the rings to be not homogeneous, but layered, composed of distinct bands, each with varying particle sizes and albedos. In some sectors, ice particles gleam brightly. In others, dust and organic residues lend a darker hue. Their differences hint at varied origins, collisions, and contaminations, a cosmic palimpsest of past events recorded in orbital debris. To parse this record is to confront the instability of celestial systems, to read in frozen fragments the traces of moons torn apart, or comets sacrificed to Saturn's gravity. The scale of their thinness remains one of the most striking aspects. If Saturn's rings were shrunk to the size of a sheet of paper, their relative thickness would be less than the width of a human hair. Yet these fragile arcs stretch across hundreds of thousands of kilometers. They represent a balance so delicate that it seems improbable, a knife's edge of orbital dynamics maintained against the crushing forces of gravity and impact. Psychologically, such scale pushes human cognition toward the limits of comprehension. Studies in cognitive science reveal how the brain struggles with orders of magnitude. Exponential growth, astronomical distances, and vast ratios exceed intuitive reasoning. Saturn's rings confront observers with precisely this limit, demanding an expansion of mental models into realms where intuition falters. The image of fragments circling Saturn, colliding and reforming, evokes parallels with the functioning of memory. Just as the brain does not store perfect replicas of experiences, but fragments of sensory impressions that are reassembled at recall, the rings are not permanent bodies, but a shifting assembly of particles perpetually reorganized. Both systems depend on constant renewal. Both are vulnerable to distortion, erosion, and loss. Yet both generate a powerful illusion of continuity. tricking the observer into perceiving stability where none exists. It is in these countless icy fragments, reflecting light as they orbit in fragile equilibrium, that the deeper paradox of Saturn's rings is revealed. Their very brightness, their stunning visibility across space, is inseparable from the fragility of their makeup. The more they shine, the more they betray their nature as fleeting assemblies, easily dismantled by time, collisions, and the slow pull of Saturn's gravity. And as scientists probed deeper into their composition, evidence began to surface that their story might not extend back to the birth of the solar system at all, but may belong to a much more recent epoch. A revelation that forces a re-evaluation of their origin and accelerates the urgency of their disappearance. For centuries, scholars assumed Saturn's rings were as old as the planet itself, born from the same swirling nebular cloud that condensed into worlds, moons, and asteroids some 4.5 billion years ago. The idea of ancient rings carried a certain comfort, a picture of stability across cosmic ages. Yet as more precise data accumulated, this view began to erode. The question of age shifted from the margins of speculation to the center of debate, and with it came a deeper recognition of how temporary even the grandest structures can be. The Cassini spacecraft delivered the decisive evidence. By carefully measuring the mass of the rings, using the tiny gravitational tug they exerted on the spacecraft's trajectory, scientists found that the rings contain far less material than expected if they had endured since Saturn's formation. The total mass of the rings is comparable not to that of a planet or even a large moon, but to a modest icy satellite, something more akin to Mimas or Enceladus. If such a fragile reservoir of matter had existed for billions of years, it would by now be coated in dust from interplanetary debris, darkened and obscured beyond recognition. Yet the rings remain dazzlingly bright, their surfaces composed largely of freshwater ice, betraying a youth measured not in billions, but in hundreds of millions of years. To place this in perspective, if Saturn itself were a 45-year-old human, its rings would be less than a year old. On cosmic scales, they are adolescents, a fleeting spectacle that may not persist long enough to be witnessed by distant future observers. This youthfulness unsettles not only astronomers, but also the human imagination. For it means that what we regard as timeless ornament is in fact a rare coincidence, a transient phase in planetary evolution. How they formed so recently remains a matter of investigation. One leading hypothesis proposes the catastrophic destruction of a moon, a satellite of icy composition, destabilized by orbital resonances or pulled inward by Saturn's gravity, may have been shredded by tidal forces, scattering debris that spread into rings. Another possibility is the capture and disintegration of a passing comet or Kuiper belt object, torn apart when it strayed too close. Each scenario implies violence, rupture, and sudden transformation rather than steady accretion. Just as memory is often reshaped not in gentle increments, but in sudden moments of trauma, so too, the rings may have been born in a single catastrophic event. This possibility of youthful rings reframes Saturn's system not as static architecture, but as a dynamic stage. Moons interact with one another in resonant chains, gravitational tugs redistribute energy, and sudden instabilities can rearrange entire configurations. The rings are the visible residue of this instability, an afterimage of celestial conflict that has yet to settle into equilibrium. Their brilliance is not a marker of endurance, but of recency, like the bright flames of a fire that has only just begun to burn. The recognition of their relative youth also raises unsettling parallels with human perception of time. Psychologists studying chronostasis, the stopped clock illusion, have shown that the brain can retroactively lengthen a brief moment to create the sensation of stability. When we glance at a clock, the first tick often feels extended, as though time itself had slowed, even though the mechanism moves on as usual. Saturn's rings may play a similar trick at the cosmic scale. Their glowing arcs appear timeless, but in truth they occupy only a brief interval, a stretched instant in planetary history that feels longer than it is. The mind, eager to impose permanence, mistakes transient radiance for eternal presence. The debate over age continues, not only because the data are complex, but because the implications reach far beyond Saturn. If its rings are young, then ring systems may be transient features throughout the universe, appearing and disappearing in cycles tied to the lifespans of moons and comets. The cosmos might be filled with unseen rings, each existing for only a geological heartbeat, most missed entirely because they form and fade between the narrow windows of human observation. This redefines our place in time, reminding us that our observations capture not a representative state of nature, but an accident of timing. In cultural traditions, fleeting spectacles have often been imbued with special meaning. The Japanese aesthetic of mono no aware emphasizes the poignancy of impermanence, finding beauty precisely in the transitory. Cherry blossoms are admired not despite their brief flowering, but because of it, their evanescence amplifying their allure. Saturn's rings, young and destined to vanish, embody the same principle at astronomical scale. Their fragility intensifies their significance, for we are among the few epochs of observers permitted to see them in their prime. The Cassini data did not silence debate, it sharpened it. Some argue that while the rings appear young, they could be old structures undergoing constant renewal. Impacts might grind away darkened surfaces, exposing fresh ice beneath. Small moons embedded within the rings could recycle material, sweeping, colliding, and redistributing particles. If so, the brightness of the rings might not indicate youth, but an ongoing process of resurfacing. Yet this alternative explanation introduces another form of impermanence. Rather than stable longevity, the rings survive only through continual loss and replenishment, an equilibrium of decay and renewal. Whichever interpretation is correct, the conclusion is the same. Saturn's rings are fragile systems in flux, dependent on collisions, erosion, and gravitational exchanges. They are not ancient monuments, but dynamic structures teetering on instability. Each particle of ice carries within it the record of collisions past and the certainty of collisions to come. And just as memory researchers note that every act of recall reshapes the memory itself, every encounter among ring particles reshapes the system, ensuring that what endures tomorrow is never quite what existed today. This fragility is not abstract, but measurable. Cassini's instruments detected streams of matter cascading inward, flowing from the rings into Saturn's atmosphere. Water molecules, dust, and organic compounds are spiraling down in what scientists have called ring rain, a process consuming the system particle by particle. It is not simply that the rings may have formed recently. It is also that they are actively disappearing now, dissolving into the very planet they adorn. The discovery that Saturn's rings are actively raining into the planet reframed them not as inert ornaments, but as systems engaged in continuous sacrifice. Cassini's detectors recorded streams of charged water molecules flowing along Saturn's magnetic field lines, plunging into the upper atmosphere at rates so great that entire Olympic-sized swimming pools of material disappear each half hour. This steady transfer is not random, but guided by the invisible geometry of Saturn's magnetosphere, a structure that bends particle trajectories like a hypnotist's pendulum, drawing attention toward a single point. The phenomenon of ring rain was first hypothesized decades earlier, when faint ultraviolet emissions were detected in Saturn's atmosphere. These emissions suggested the presence of water vapor, out of place in a hydrogen-helium giant. It was only with Cassini's close passes that the scale of the influx was revealed. Tens of thousands of kilograms of icy material per second, cascading downward like an unending storm of invisible hail. In planetary terms, this is a torrent, and it means that the rings are eroding as they feed the planet, surrendering their brilliance to sustain Saturn's mass. The mechanism that drives this process is a complex interplay of gravity, magnetism, and radiation. Saturn's gravity pulls particles inward, but the magnetic field shapes their descent, channeling them along arcs invisible to human eyes. Ultraviolet light from the sun further accelerates the process by charging dust grains, making them responsive to electromagnetic forces. The result is a coordinated transfer, a constant siphoning of icy debris from orbit to atmosphere. It is a planetary-scale illusion of stability concealing unceasing attrition, as if a cathedral of crystal were quietly dissolving while appearing intact from a distance. The psychological dimension of this hidden rain resonates with how human beings often experience loss. Neuroscientists studying synaptic pruning have shown that the brain's structure is maintained by the selective elimination of connections. Every moment of learning is also a moment of erasure. Just as Saturn's rings gleam only by surrendering particles to the planet below, the brain refines itself by letting go of neural pathways that once carried meaning. The cost of coherence is sacrifice, a principle mirrored across scales from neurons to planetary systems. Cassini's instruments captured not only the chemistry of this rain, but its effects on Saturn's upper atmosphere. Regions where the influx is strongest show alterations in ionospheric density, creating dark bands when measured in radio wavelengths. These atmospheric fingerprints map the paths of particles falling from orbit, invisible rivers feeding into the gas giant. To human perception, Saturn remains serene, its clouds undisturbed by the faintest suggestion of what is occurring above them. Yet, to instruments sensitive enough to detect shifts in plasma density, the truth emerges. The planet is consuming the luminous structures that define its appearance. The scale of the loss is staggering. Current estimates suggest that within 100 to 300 million years, the rings will be gone, their material absorbed into Saturn's bulk or dispersed into space. While such timescales dwarf human lifespans, they are brief compared to planetary history. The rings, so prominent in our telescopes, are a fleeting performance, one that began recently and will end almost as quickly. Their grandeur, like a sensory illusion in the mind, derives from a trick of timing. We exist in the interval where they shine brightest, unaware of how rapidly their form is dissolving. Ring rain has consequences beyond erosion. As particles plunge into Saturn's atmosphere, they deliver not just water, but also organics, silicates, and dust. These materials alter atmospheric chemistry in ways scientists are only beginning to understand. Molecules may catalyze reactions in the ionosphere, changing the reflective properties of Saturn's upper layers. Such transformations echo the way subtle inputs, a suggestion whispered under hypnosis, a rhythm imposed on brain waves, can reconfigure human perception and behavior without altering the deeper structure. What appears as a minor transfer conceals a more profound reshaping of the system itself. Historical parallels remind us that great structures have often been undone by unseen forces. The walls of ancient cities, celebrated for their strength, often fell not to armies at their gates, but to erosion, rot, and the slow undermining of their foundations. The Great Library of Alexandria did not vanish in a single blaze, but through gradual neglect, dispersal, and repeated damage. Saturn's rings, too, are not collapsing in a dramatic instant, but yielding silently, grain by grain, to forces invisible to casual observers. What remains luminous in the night sky conceals an unrelenting decay that has already determined its outcome. The metaphor of rain carries a symbolic weight across cultures. In myth and ritual, rain has been both blessing and threat, life-giver and destroyer. It erodes mountains even as it nourishes fields. Saturn's ring rain carries the same duality. It destroys the structure of the rings, even as it alters and perhaps enriches Saturn's upper atmosphere. The dual nature of this process, creation through destruction, forces recognition of cycles far larger than human experience, cycles in which beauty is inseparable from its own dissolution. The unease provoked by these findings lies in the realization that what seems enduring can be measured in vanishing increments. Cassini's data turned permanence into countdown, stability into depletion. The rings no longer stand as static ornaments, but as flows of matter in transition, their brilliance dependent on a constant loss too subtle to perceive without instruments. And beyond the spectacle of erosion lies the unsettling awareness that the very forces erasing them are still at work, accelerating under the bombardment of micrometeoroids, collisions, and invisible currents of radiation that grind the fragments down into dust. The ring rain is only one of many destructive forces at work. Even if Saturn's magnetic fields and gravity did not pull icy material inward, the system would still be under constant assault from beyond. Interplanetary space is not empty, but filled with a ceaseless stream of micrometeoroids, fragments of rock and dust left behind by comets, shattered asteroids, and collisions from earlier epochs. These particles, often no larger than grains of sand, travel at velocities reaching tens of kilometers per second. When they strike Saturn's rings, the collisions are catastrophic on the microscopic scale. Each impact shatters ice particles into smaller fragments, scattering dust that gradually coats the pristine surfaces. Over time, this darkens the rings, diminishing their brilliance and revealing how fragile their luminosity really is. Laboratory experiments on Earth, such as hypervelocity impact tests conducted at NASA's Ames Research Center, show that collisions at these speeds vaporize ice instantly, producing jets of gas and sprays of fine particles. The same processes are unfolding continually within Saturn's rings, grinding their structures down with relentless efficiency. The collisions are not limited to micrometeoroids. Ring particles themselves are in constant motion, orbiting Saturn at slightly different speeds depending on their distance from the planet. This differential rotation ensures that even neighboring particles occasionally collide. While most encounters are gentle, some occur at velocities sufficient to fragment aggregates, breaking apart clusters and reshaping local regions. The system is in perpetual flux, a balance sustained only by the interplay of shattering and reaggregation. The human brain, when studied under electroencephalography, displays a similar balance. Neural oscillations constantly synchronize and desynchronize, producing coherence only through cycles of fragmentation and reassembly. Saturn's rings mirror this oscillatory instability, their apparent solidity masking a state of ceaseless disintegration. Over geological spans, these collisions produce a slow contamination. Darker material from impacts accumulates on icy surfaces, lowering their reflectivity. Observations by Cassini revealed that some regions of the rings are significantly darker than others, bearing the scars of continuous bombardment. This distribution is uneven, shaped by gravitational resonances with Saturn's moons that concentrate particles in particular regions, amplifying the violence of collisions. The consequence is a layered record of destruction, a palimpsest of impacts that continually alters the ring's appearance. Even more subtle are the erosive effects of Saturn's own radiation environment. The planet's magnetic field traps high-energy particles, forming radiation belts that bombard the rings with charged ions and electrons. These interactions sputter material off the icy surfaces, ejecting atoms into space and gradually thinning the ring's mass. Cassini detected plumes of hydrogen and oxygen liberated in this way, evidence of atomic-scale attrition invisible to telescopes. Erosion here is not dramatic but cumulative, a steady depletion that parallels the way memory degrades not from single traumas alone but from the slow wear of time and interference. The analogy extends further when one considers the role of small embedded moons. the so-called shepherd moons that orbit within or near the rings. Moons like Pan, Daphnis, and Prometheus carve channels, edges, and waves, creating intricate patterns that ripple outward. Yet these same moons also destabilize particles, pulling them into new trajectories, enhancing collisions, and redistributing debris. Their actions preserve the architecture of the rings, even as they amplify the processes that will ultimately thin them. It is a paradoxical guardianship: preservation through disruption, stability through constant rearrangement. Human perception finds echoes of this paradox in the experience of illusions such as the flicker fusion effect. When light flashes rapidly enough, the brain interprets it as continuous illumination. The stability is real in experience, but false in mechanism, dependent entirely on disruption occurring faster than perception can resolve. Saturn's rings function in an analogous way. Their striking stillness is not true stasis, but the product of collisions, impacts, and erosions occurring at such scale and frequency that human observation translates them into permanence. The mind, unable to perceive chaos at planetary scales, substitutes the illusion of order. The violent forces acting on the rings also suggest that their lifetime may be shorter than estimates based solely on ring rain. If micrometeoroid bombardment accelerates, or if a destabilizing event involving one of Saturn's moons occurs, the erosion could proceed at a pace that outstrips predictions. Planetary scientists calculate rates of impact by sampling interplanetary dust with detectors such as Cassini's cosmic dust analyzer, which recorded thousands of high-speed collisions during its mission. These data show that the solar system is not a quiet place, but an environment of constant attrition. Saturn's rings, situated as broad, thin targets, are among the most vulnerable structures in this environment. This vulnerability recalls historical instances where grandeur was undone not by singular catastrophe, but by relentless attrition. The Colosseum in Rome was not demolished in one event, but eroded by centuries of stone robbing, weathering, and seismic shifts, leaving an incomplete shell that nevertheless conveys its former magnificence. Saturn's rings exist in a comparable state of erosion, their splendor maintained only by fragments surviving countless collisions. To gaze upon them is to look at a monument already being dismantled, yet still luminous in its incompleteness. The recognition of these erosive processes shifts the rings from symbols of cosmic harmony to records of ongoing violence. Their arcs are not tranquil halos, but arenas where forces beyond human comprehension play out on unimaginable scales. Every moment brings new impacts, new fractures, new rearrangements, and every one of them leaves behind traces that compound over time. The image of Saturn adorned with perfect rings conceals a battlefield of attrition, an unending struggle between creation and destruction measured in fragments of ice no larger than grains of salt. And yet, these processes do not isolate themselves. The very fragments broken loose by collisions and erosion can migrate inward, joining the streams that plunge into Saturn's atmosphere. The distinction between ring rain and erosion is not absolute, but interconnected, part of a larger cycle of loss where every collision contributes to the gradual consumption of the rings. In this sense, the system is cannibalistic. Each impact both maintains the illusion of brightness and accelerates the collapse. It is a structure that sustains itself only by hastening its own erasure, a paradox as unsettling as it is inevitable. The Cassini spacecraft's final orbits around Saturn were conceived as both sacrifice and revelation. Engineers and scientists knew the probe could not last indefinitely. Its fuel reserves were dwindling, and without control, it would eventually drift unpredictably. To avoid the risk of contaminating moons like Enceladus or Titan, worlds that may harbor conditions suitable for life, mission planners devised a controlled plunge into Saturn's atmosphere. These last orbits, known as the grand finale, carried the probe directly between the rings and the planet, a trajectory no spacecraft had attempted before. During these close passes, Cassini became both explorer and witness, threading the narrow gap where gravity, magnetism, and ring material intersect. Instruments measured particle densities, magnetic fields, and radiation levels in unprecedented detail. The probe, skimming only a few thousand kilometers above the cloud tops, flew through a region where fragments of the rings were actively streaming inward. In these moments, Cassini became part of the very process it was documenting, passing through the veil of matter that links the rings to the planet below. The data were startling. The space between the rings and Saturn was not empty, as some had predicted, but filled with complex flows of particles and charged molecules. Instruments detected torrents of water-derived material raining into the atmosphere, confirming the scale of the erosion. They also revealed an unexpected abundance of organic compounds, complex hydrocarbons that suggested the rings were not composed of ice alone. The descent of these materials into Saturn's atmosphere hinted at chemical interactions that may alter the planet's composition, reshaping it in ways still poorly understood. The descent itself was carefully choreographed. Cassini's orientation was continually adjusted so that its antenna dish acted as a shield, protecting vulnerable instruments from high-speed particles. Every orbit cut deeper into the unknown, each pass collecting a stream of data transmitted back to Earth across more than 1 billion kilometers of space. The final sequence of orbits compressed years of scientific investigation into mere months, accelerating discovery at the cost of the spacecraft's survival. What emerged from these measurements was a portrait of Saturn's rings not as passive adornments, but as dynamic systems locked in exchange with the planet. Cassini detected that the rate of mass loss from the rings is higher than once believed, suggesting that their disappearance may occur on shorter timescales than earlier estimates allowed. While some models propose lifespans of hundreds of millions of years, Cassini's measurements indicated erosion that could reduce them far sooner if conditions accelerate. There was also the question of structure within the rings themselves. Cassini's instruments mapped density waves, spirals, and gaps with exquisite precision, revealing how Saturn's moons sculpt the debris into shifting patterns. These patterns are not static but evolve rapidly, sometimes over just years or decades. The spacecraft documented how resonances with moons like Mimas generate gravitational tugs that ripple through the rings, shaping arcs into alternating bands of density. These structures are not unlike the rhythms imposed on the human brain during hypnosis or meditation, when oscillations align to external stimuli. Just as rhythm and repetition entrain neural activity, Saturn's moons impose synchronization on icy fragments, creating coherence out of chaos. Cassini's final dive in September 2017 was itself transformed into a ritual of knowledge and erasure. As the spacecraft entered Saturn's atmosphere, it transmitted data until aerodynamic forces tore it apart. The probe's destruction became part of the very story it was recording. The rings raining into Saturn, Cassini dissolving alongside them, both consumed by the planet's vastness. The act symbolized the principle that to know something fully often requires surrender, just as mystics across cultures have described the dissolution of self as the gateway to insight. Cassini's sacrifice mirrors this pattern, an ending that delivered clarity only by erasing the vessel of observation. From these final observations came evidence that the mass of the rings is not great enough to endure indefinitely. The brightness of the particles, the abundance of fresh ice, and the sheer rate of material loss combine into a picture of impermanence. What telescopes from Earth present as a stable halo is in fact the residue of ongoing depletion, a structure that exists only through constant attrition. Cassini made it impossible to see the rings as eternal. Its data transformed them into temporary architectures dissolving before our instruments. Yet the very precision of these measurements sharpened uncertainties. If the rings are younger and disappearing more rapidly than once thought, then their presence during human history is an extraordinary coincidence. They may not have existed during earlier civilizations' first observations of the night sky, and they may not exist for civilizations yet to come. This rarity deepens the sense of transience, situating humanity within a narrow observational window, one that could close long before new intelligences have the chance to witness the spectacle. The paradox is that the closer Cassini approached Saturn, the less permanent the rings appeared. Their brilliance, measured against the backdrop of loss, became not a symbol of stability, but of vulnerability magnified. Each fragment of ice reflected sunlight while falling toward destruction, embodying a beauty inseparable from disappearance. The spacecraft's final dive crystallized this reality, recording the system at the same time that it entered into the very process of erosion. What remained was an unresolved tension. Cassini's data exposed the mechanisms of loss, yet left unanswered the question of timescale. Predictions range from tens of millions to hundreds of millions of years, a gulf that underscores the uncertainty inherent in planetary dynamics. The rate of erosion may vary, accelerations may occur, or replenishment from unseen events may complicate the story. Just as human memory is altered each time it is recalled, stable in appearance but unstable in mechanism, the rings appear enduring, yet may shift dramatically under forces still beyond full calculation. The unanswered questions now form the frontier. What controls the precise rate of erosion? What roles do Saturn's moons play in sustaining or dismantling the system? How might hidden reservoirs of material replenish the rings? Or are we witnessing a spectacle with no replacement? The ambiguity lingers, carrying with it a sense of unease that grows sharper the more precisely the data are measured. The question of how long Saturn's rings will remain visible presses against the limits of scientific certainty. Cassini's measurements provided a foundation, but translating those observations into forecasts requires extrapolation across timescales the human mind is poorly equipped to imagine. Estimates suggest the rings may vanish within 100 to 300 million years, a blink when compared with the 4.5 billion-year age of Saturn itself. Such numbers carry a strange duality. They are unimaginably vast relative to human lifespans, yet minuscule against planetary and cosmic history. This disparity between perception and reality has been studied extensively in cognitive psychology. Humans struggle to conceptualize exponential change, vast distances, and long durations. Research into temporal construal theory shows that as events move further into the future, the mind represents them in increasingly abstract terms, stripped of detail and urgency. A millennium seems unreal, a million years incomprehensible. Yet within such spans, planetary systems undergo transformations as profound as the evolution of life on Earth. The projected disappearance of Saturn's rings inhabits this psychological blind spot, too remote to grasp viscerally, yet too imminent to dismiss in cosmic context. The mechanisms driving their erosion introduce additional uncertainties. Micrometeoroid bombardment, ring rain, and electromagnetic stripping are not steady processes. Their rates fluctuate with solar activity, cometary influx, and the gravitational alignments of Saturn's moons. A surge in meteoroid density, perhaps triggered by a disrupted comet, could accelerate erosion by orders of magnitude. Conversely, an unforeseen event, such as the capture of a new icy body, might replenish material, extending the ring's lifespan. Models attempt to capture these contingencies, but they remain sensitive to initial assumptions, leaving wide margins of error. The very act of forecasting becomes entangled with illusion. Psychologists studying judgment under uncertainty, such as Daniel Kahneman and Amos Tversky, describe how the mind relies on heuristics, mental shortcuts, that often distort probability. One such bias, the availability heuristic, leads us to estimate likelihood based on vividness and familiarity. Because Saturn's rings have always been present in the telescopic era, the mind assumes they will remain. The data contradict this, yet the visual persistence of the rings reinforces the illusion of permanence. Science offers numbers, but perception resists their implications. Astronomers attempt to resolve the question by comparing Saturn to other ring systems in the solar system. Jupiter, Uranus, and Neptune each possess rings, but theirs are faint, tenuous, and easily overlooked. They suggest that Saturn's luminous arcs are an exception rather than a rule, and exceptions by definition imply rarity. If Saturn's rings were primordial, one would expect more robust systems around other giants. Instead, the evidence points toward transience, reinforcing the view that Saturn's spectacular halo is a temporary state, the possibility that we live during the narrow window of their existence raises unsettling reflections about coincidence and perspective. Philosophers of science have debated the anthropic principle, the idea that our observations of the universe are conditioned by the fact that we exist within it. Applied here, the thought emerges that humanity observes Saturn's rings not because they are common, but because we happen to exist during their rare flourishing. It is an accident of timing, a reminder that human perspective is shaped as much by circumstance as by universal law. The implications stretch further. If Saturn's rings are transient, then the cosmos may be filled with structures that appear only briefly, unseen by most civilizations or instruments. Entire categories of celestial phenomena could arise and vanish between epochs of observation, hidden not by distance, but by timing. The universe, like the mind, may present only fragments of a larger reality, leaving vast intervals unseen. This prospect reshapes how we interpret not just Saturn, but the very act of cosmic observation, situating us within a fleeting vantage point that may never recur. On Earth, human cultures have often grappled with impermanence through ritual and narrative. Ancient Mesopotamian texts describe the world as fragile, always at risk of dissolution by flood or invasion. Buddhist traditions emphasize the transient nature of all phenomena, teaching that clinging to permanence produces suffering. The rings of Saturn resonate with these insights on a cosmic scale, embodying impermanence not as metaphor, but as measurable process. Their erosion is not speculation but observation, a slow unraveling written into the data of spacecraft and telescopes alike. Cassini's final results suggested that the ring's brightness conceals rapid depletion. What appears dazzling to the human eye is, in fact, the glow of a structure already collapsing. Like a candle that burns brightest just before it extinguishes, the rings may be most luminous at the moment of their greatest fragility. This recognition alters the meaning of their beauty. They are not monuments of endurance, but spectacles of transience, their radiance inseparable from their decline. Yet even with this awareness, the timeline remains unresolved. Predictions of 100 million years are based on present rates of loss, but those rates could shift. Some processes may accelerate as the rings thin, exposing particles to greater bombardment. Others may decelerate if surviving fragments settle into more stable orbits. The system resists simple extrapolation, its complexity ensuring that every forecast carries uncertainty. This uncertainty itself becomes part of the tension. The rings are disappearing, but how quickly and by what precise pathways remain questions unanswered. It is in this ambiguity that the unease deepens. The recognition that Saturn's rings are temporary is destabilizing enough, but the inability to pin down their future amplifies the disquiet. We are left suspended between scales of time, caught in the awareness that what appears timeless is already unraveling, yet unable to predict when the spectacle will pass. The rings continue to gleam, silent and vast, while beneath their brilliance lies a process of erosion whose pace remains beyond our full grasp. The fading of Saturn's rings carries implications beyond aesthetics. It transforms our understanding of planetary systems as living, dynamic environments. For centuries, The prevailing conception of the heavens was one of stability, a cosmic architecture of immutable forms. Even after Copernicus displaced Earth from the center, the planets themselves were thought to be unchanging, circling endlessly in perfect cycles. The erosion of Saturn's rings challenges this ancient expectation, demonstrating that planetary systems evolve visibly, not only through hidden processes but in ways that alter their very appearance. Astronomers studying exoplanets have long relied on models of planetary disks, vast rings of gas and dust, surrounding young stars from which planets coalesce. These protoplanetary disks are transitory, dispersing in a few million years as material either forms into planets or is blown away by stellar winds. Saturn's rings, though much smaller and composed of ice rather than gas, present a miniature analog of these processes. They remind us that the cycle of accretion and dispersal is not confined to stellar nurseries, but continues across planetary systems. The same forces that shape distant exoplanetary disks are at work in Saturn's halo, erasing what once appeared immutable. The disappearance of the rings also provides a laboratory for testing theories of orbital mechanics and material evolution. The gravitational interactions between moons, rings, and the planet create resonances that drive patterns of erosion and structure. These interactions reveal the fragility of equilibrium in celestial systems. A moon tugging at just the right frequency can open a gap or trigger a spiral wave across thousands of kilometers. The delicacy of this balance recalls the way small perturbations in brain activity can induce profound shifts in consciousness, seizures, trance states, or moments of insight. Just as neural systems exist on the edge of instability, Saturn's rings are balanced on thresholds where minor forces produce large-scale transformations. What emerges is a recognition that beauty in cosmic structures often arises from instability. The rings' arcs and divisions, their shimmering brightness and sculpted edges, are products of processes that ensure their eventual dissolution. The same pattern occurs in human phenomena. A snowflake's geometry exists only under conditions that will soon destroy it. A soap bubble glows iridescent just before bursting. Saturn's rings participate in this larger law of fragile order, where spectacle and transience are inseparable. The awareness of this fragility raises questions about human meaning-making in the face of impermanence. Psychologists have shown that the human mind struggles with the concept of entropy. People naturally assume systems tend toward order rather than disorder, a bias rooted in cognitive ease and reinforced by everyday experiences of maintenance and repair. Yet the second law of thermodynamics ensures that entropy dominates, and Saturn's rings are one of its grandest demonstrations. Their erosion is not an accident, but a necessity, a planetary-scale expression of the same principle that ensures ice melts, memories fade, and civilizations erode. In mythology, rings often symbolize continuity, cycles without beginning or end. From wedding bands to sacred circles, human cultures imbue rings with permanence. Saturn's luminous arcs appear to embody this archetype, a celestial confirmation of eternal recurrence. Yet science reveals them as temporary, undoing the archetype itself. The contrast between appearance and reality creates an almost unsettling dissonance. The heavens reflect our deepest symbols, but only as illusions. The psychological effect is not unlike optical illusions studied by Gestalt theorists, where the brain perceives closure and symmetry where none exists. Saturn's rings are the cosmos performing a Gestalt trick, offering the image of permanence where only disintegration persists. The consequences of their disappearance extend to Saturn itself. As ring material descends into the atmosphere, it alters the planet's chemical balance and redistributes angular momentum. The infall of water molecules modifies ionospheric density, while the loss of orbital debris influences the dynamics of Saturn's magnetic field. These are not passive changes, but transformations that may reshape the giant planet's evolution. In this sense, The rings are not only vanishing but actively rewriting the planet they surround, erasing themselves by altering their host. The act is reminiscent of synaptic pruning in the brain, where unused connections are cut away, not merely to vanish but to refine the system, shaping its future function. There is an eerie symmetry in how Saturn consumes the very structures that make it iconic. The planet draws down icy particles in a ceaseless rain, eroding its halo while feeding on it. The beauty admired from Earth is, in effect, a slow meal, a self-cannibalizing process in which the planet adorns itself with fragments it is already digesting. The spectacle becomes unsettling once the mechanism is understood, shifting from elegance to predation, from permanence to consumption. The broader lesson reverberates into how humans perceive time and legacy. Just as Saturn's rings are temporary, so too are Earth's landscapes, climates, and civilizations. Archaeology is filled with examples of societies that believed their monuments eternal, only to leave behind fragments buried in dust. The erosion of Saturn's rings provides a planetary-scale reminder that nothing resists the universal tendency toward dissolution. It strips away comforting illusions, leaving the stark recognition that even the most magnificent structures are transient expressions of unstable balance. And yet, this recognition does not diminish their power. Instead, it heightens it. Beauty bound to impermanence acquires a sharper intensity, a resonance amplified by its fragility. Saturn's rings, gleaming across telescopes and spacecraft images, invite awe not despite their dissolution, but because of it. They embody the paradox that what fades is most cherished, that what cannot last demands the deepest attention. This paradox presses forward, urging inquiry not only into their mechanisms of loss, but into the meanings humans ascribe to their vanishing, an inquiry that stretches beyond astronomy into psychology, philosophy, and culture. The recognition that Saturn's rings are impermanent reframes them not only as astronomical curiosities, but as case studies in planetary evolution. They are more than luminous arcs in a telescope. They are laboratories of instability, offering insight into how matter circulates within complex systems. When astronomers look at the rings, they are not merely witnessing erosion, but observing a process that reveals the pathways by which moons form, dissolve, and interact with their planetary hosts. The rings' mass, composition, and dynamical structure provide analogues to the processes that once shaped the early solar system. Protoplanetary disks around young stars exhibit many of the same features: spiral waves, gaps created by orbiting bodies, and turbulence that redistributes material. Saturn's rings are a scaled-down experiment, repeating in miniature what shaped the architecture of worlds. To study them is to glimpse echoes of the past, how Earth, Mars, and the other planets once gathered from dust and debris suspended in orbit. Their disappearance removes more than beauty. It erases an active reference point for understanding the forces that forged planets themselves. Cassini's findings suggested that as the rings erode, Saturn's moons also record the consequences of this shifting balance. Resonances between orbits transfer energy, altering trajectories, and even changing the tilt of Saturn's axis. Some researchers argue that the migration of moons like Titan and Enceladus may be linked to the ring's instability, each component of the system tugging on the others in feedback loops that reshape the planet's long-term evolution. The rings are not an isolated ornament, but a participant in a network of gravitational negotiations. This interconnectedness undermines the assumption of celestial isolation. Every component is a thread in a larger fabric of shifting tensions. The fragility of this fabric reveals something unsettling. Stability in planetary systems is never absolute, but conditional. Historical models of celestial mechanics once emphasized predictable order, a universe running like a clock. Yet modern studies show chaos theory woven into orbital dynamics, where small perturbations can trigger disproportionate effects over long timescales. Saturn's rings embody this sensitivity. A slight increase in micrometeoroid flux, a small resonance shift from a migrating moon, or a surge of solar activity can accelerate erosion, redirecting the system onto a path that diverges dramatically from earlier predictions. Their impermanence is not just measured in countdowns of mass loss, but in the unpredictability of compounding forces that operate across scales. Psychological parallels emerge in how humans process unpredictability. Studies on uncertainty tolerance show that individuals often prefer negative certainty over ambiguous futures. The mind is uneasy when outcomes remain unresolved. Saturn's rings impose this unease on a cosmic scale. Their disappearance is inevitable, but the rate, mechanisms, and consequences remain indeterminate. They occupy a liminal state, visible yet vanishing, their timeline both measurable and uncertain. The tension lies not only in their fragility, but in the inability to fix their trajectory with precision. The ring's gradual erosion also illuminates the nature of planetary atmospheres. As icy particles plunge into Saturn, they deliver not only water, but organic molecules that interact with atmospheric chemistry. This influx may produce compounds not otherwise present, altering cloud structures or ionospheric conductivity. In effect, the rings function as both a veil and a reservoir, shielding Saturn in part while simultaneously seeding its upper layers with foreign material. Their disappearance will not leave Saturn unchanged. It will reshape its atmospheric behavior, potentially altering the planet's electromagnetic environment for ages to come. Viewed in this way, the rings embody cycles of exchange, dissolving distinctions between adornment and substance. They are not external decorations, but integral to Saturn's evolving identity. Their erosion is not a peripheral process, but a core transformation, weaving loss into the very fabric of the planet. It is as though the line between surface and ornament has blurred, as though Saturn's beauty is inseparable from its consumption of that very beauty. In human terms, this intertwining recalls cultural practices in which symbols of power are consumed to embody their essence. In some traditions, consuming a sacred meal or burning an offering transforms the material into part of the sacred whole. Saturn's rings participate in a similar ritual of dissolution, their fragments drawn into the atmosphere as offerings that alter the planet itself. What looks like loss from afar is also integration, the halo becoming inseparable from the body it surrounds. The recognition of these processes forces a reconsideration of permanence not only in astronomy, but in human culture. The instinct to treat visible grandeur as eternal is confronted by data showing its impermanence. Just as ancient monuments erode under wind and weather, just as neural pathways fade without reinforcement, so too do planetary structures dissolve under forces that appear invisible until measured with precision. The difference is scale, not principle. The ring's impermanence becomes, paradoxically, a revelation of continuity. They link human perception of fragility to universal laws of entropy and exchange. They remind us that impermanence is not an exception but the governing condition, and that the illusion of permanence emerges only from the limits of perception. The rings shine because of their instability. They endure only through erosion. They enchant because they are already vanishing. Yet the implications stretch further still. If Saturn's rings are temporary, then our current image of the solar system, its diagrams, its cultural representations, its very iconography, may belong only to this moment in time. Future skies may hold a Saturn bare of its luminous arcs, transformed into a planet less adorned, less symmetrical, yet no less real. The thought unsettles, for it reveals how what seems timeless in human imagination may belong only to a fleeting epoch. And beyond this recognition lies the larger question: what will Saturn be without its rings? And how will that transformation alter our understanding of planetary identity itself?